Okay, I want to determine mass. Enter the data for momentum. We have given momentum is equal to 500 gram meter per second over velocity is 10 meter per second. So you see a meter per second and a meter per second will cancel, will remain with gram. 500 over 10, we get 50, but it is a gram. So we say that the mass of object is 50 gram. So this is how to calculate that question. From there, let's go on how to apply the Newton's second law of motion to calculate different problems. Let's recall from Newton's second law of motion, we have said that Newton's third law of motion states that the rate of change of linear momentum is directly proportional to the force applied and takes direction to that force. And we have said that Newton's second law of motion, it shows the relationship between force, mass, and acceleration. We have reached the point that Newton's second law of motion shows relation between force and the mass and the acceleration. Force is equal to mass times the acceleration. Also, we know acceleration is obtained by taking the change of velocity over time. Change of velocity is obtained by taking final momentum or final velocity minus initial velocity over time. So this formula will be used to solve different problems. Let's put this as an example 4. The example states that a football was kicked into hands of a goal and stopped at 4 meter per second, and the goalkeeper stopped the ball in 2 seconds. If the mass of ball is 0.5 kilogram, calculate the average force exerted, the average exerted by a goalkeeper. For given a football was kicked into hands of a goalkeeper and is stopped at 4 meters per second. The goalkeeper stopped the ball in 2 seconds. The mass of a ball is 0.5 kilogram. Calculate the force exerted by a goalkeeper. From there, first we have to write data. So solution, write data given. We have given a football was kicked into hands of keeper, stopped at 4 meters per second. So the initial velocity of the ball will be 4 meters per second. So V initial will be equal to 4 meters per second. Also, we have, if the ball was going to stop, so if the ball stopped, the final velocity of it must be 0 meters per second because the ball was going to stop in hands of a goalkeeper. And the goalkeeper stopped the ball in 2 seconds. So the ball stopped after 2 seconds. So time equal to 2 seconds. The mass of the ball were given, mass is equal to 0.5 kilogram. This is the mass of the ball. Required what? Required average force. That is the net force. Required force F is equal to how much? So to do this question, we have to apply the concept from Newton's second law of motion. In which Newton's second law of motion shows the relationship between force, mass, and the acceleration. So it's say from F is equal to ma, but A is equal to V initial minus V final, V final minus V initial over time. So it is M bracket V final minus V initial over time. So from there we can enter data that we have given. We are given initial velocity is equal to 4 and the final velocity is equal to 0. So mass we have given is equal to 0.5. So it's equal to 0.5 kilogram. Bracket final velocity is 0 meter per second and the initial velocity is 4 meter per second over time, which is 2 seconds. So from there we calculate force. 0 minus 4 we get negative 4. So it's equal to 0.5 kilogram negative 4 meter per second over 2 seconds, which will be this 0.5 is equal to a half. So a half of 4 is equal to negative 2. Get negative 2 kilogram meter per second over 2 seconds. We'll obtain force is equal to negative 1 kilogram meter per second square, by which kilogram meter per second square is equal to Newton. So the average force will be equal to exerted average force exerted by a goalkeeper is 1 Newton. This negative, it means that the force was applied in opposite direction of the ball, because in Newton's first law of motion, I've seen that to stop a ball, we have to apply a force, or to stop an object, you have to apply a opposite force in direction of motion. So after that, let's see the last example. These examples you can do, or let's do the last example, and after that we'll be given a short task to know if we can apply the concept from linear momentum and the Newton's second law of motion to calculate the question. Let's do this simple question. The question states that what mass will be given an acceleration of 5 meters per second square by a force of 2 Newton. What mass? So the thing you're asked is mass. Light solution and light data given. The data that we're given is mass. We are required mass, but we have given acceleration, which is 5 meters per second square, and we have given force is equal to 2 Newton. So from there, say from F is equal to ma, m will be F over A. Force is equal to 2 Newton, and the acceleration is equal to 5 meters per second square. So here m will be equal to 2 over 5. If you take 2 over 5, will be equal to 0. If we add 0, 20 over 5 get 4. So mass of a body will be 0.4 kilogram. So sometimes you can be given force and mass, you have to determine acceleration, or you can be given acceleration and mass, you have to determine force. Use this formula exchangeably to solve different problems. So after that, this will be the end of the lesson. Let's give you a short task to do in order to check for your understanding. The question states that a body of mass 500 kilogram was moving at a speed of 30 meters per second, and it is brought to rest in 10 seconds. Calculate 1. The acceleration of the body. Calculate the acceleration of the body, and the second, the average force applied. The average force applied. So go and perform this task, and this will be the end of our session today. Welcome to another session. Thank you for watching.
Purchase your tracks